Hello guys, welcome back to my channel again. I hope you guys are doing good. Yeah, so let's go over this. Let's see right here. We're gonna move this over. And yeah, more on logs because I'm getting a lot of questions on logs. So let's start our lesson today. We're gonna start with, before we go over logs, because what logs is again is the converting from the exponent. Log is basically a switch of exponents. So let's go ahead and review some popular questions that I've been getting. So like something like this, right? Okay, so what should I do first here? Okay, what we should do first is let's get rid of the 12, right? Okay, so this is gone. So we're left with this. Now, usually what I do is to minimize error is I put a parentheses there. Okay, so it's gonna be 32, right? So now what we have to do, the next thing you have to do is you have to look at 32 and you're like, okay, how could I change the 32 so that we could make it into some kind of, exponential. So 32, if you remember, it's going to be 2 times 2 times 2 times 2 times 2. So it's going to be 2 to the 5th, right? So the base is same now, so we could actually cancel this out. And then what we end up with is actually this right there. And all you gotta do is solve for that problem right there. And that's what we get right over there. Okay. So yeah, go ahead and make sure you guys check your answer because that's another important thing is to check your answer. Okay. So if you plug it back in there, it actually does work. And let me change the color on my, let's see, how do I change this color? Yeah, let me change it to green here now. Okay. And then, maybe show tab like that. Okay, I like this setting better. Okay, so now I'm gonna try to squeeze the next problem in here. So we have another problem. We have log base 6 4x squared. I have to write a little small because this problem's kind of base 6 is equal to 2. Okay, now it's asking you to solve again. Solve for x. Okay, so how do I do this one? I give you, well, few seconds to look at it. Now, if you could tell, the base is the same, right? They both have log base of 6. Now, as you recall from one of the properties of logs, okay, we have this minus. Remember, logs, when you subtract, it becomes a division. So we have to divide. Now, again, what I do is to minimize error, I put the parentheses there. Okay. So now we made it into a little bit of more simplified format there. And what we have to do is we have to convert the log into exponential. Okay. So what we're gonna do is we take the base of 6. And remember, the x and the y is going to switch. So the 2 comes over here, and the whole parentheses comes right there. Okay. This shows, if you understand this, then you understand the basic log property. Okay. So now we could just go ahead and simplify, right? We could simplify. This is 36, and these two cancel out. Now notice that x cannot be 0 because there's a restriction for that. And then we get 4x right there, and then we divide by 4, and x equal to 9. But always check back. Make sure you plug it back in and make sure that the domain restrictions are satisfied. And it looks like in this case, everything is satisfied there. Okay. So one quick thing before we go on again. Now I'm getting this question over and over again. So I want to go over this part. Okay. For the logs. Okay. So I'm looking at the Ingenuity notes here, and And let me change the drawing for the notes. Okay, so if you have like log base b n to k, okay, this is just notes. Okay, your little side note. And you want to convert, remember this gets converted to bk to n, right? Okay, on the last problem, that's what we did. But notice that b cannot be 1, okay, and b and n has to be greater than 0. Okay, so it has to be positive. Okay, this is remember, you have to remember the restriction. Okay, so what I'm going to do for you right now is I'm going to highlight this because this is such a key concept, this and this and this. Okay, if you understand this, then you understand the definition of log. Okay, so this is right here, the definition of logarithm. So we just put log. Okay, I'm gonna put a little star on this as well. Okay, so now again, this is really huge. Okay, because if you don't understand this, then you cannot do logs. Okay, so let's go ahead and do another challenging problem from the student. Popular question. Okay, so I want to leave this note here. So let me just continue to work here. Another problem. Okay, so we have 2 log base 3. Okay, and then this is let's see right here. We have x right there, right? And then we have log base 3, 4x is equal to, I'm running out of space right here, so I'm gonna have to squeeze it in. Okay, 2 log base 3, and this is x plus 2 right there. Okay, so this right here, what's the first step? Well, first step is, again, is minus. Okay, remember, if this is plus, we're plus, then we're gonna have to multiply, right, in logs. So this one, what we're gonna do first is be careful of all the traps. Okay, first we have to put the 2 right here on the exponent. So what we're gonna do first step is this is what we're gonna do first. Okay, and then we're going to again go ahead and rewrite this. Okay, looks a little bit better now, right? Okay, now what's the next step? Okay, now let me go down a little bit more so I have more space here. Okay, oh, I went too much down. Believe it or not, Microsoft Word it writes best on this platform. I tried other apps, and it looks like Microsoft Word is the most precise compared to others. Okay, and anyways, okay, I don't know why it's doing that, but okay. So here we have now we're gonna use the division here. And make sure that, because minus, it becomes division, make sure you put a parenthesis there so it'll be a lot more clear. Okay, and then here you could also put log 3, and the 2 also goes up there, which is the power property. Okay, the power property of log. Okay, now it gets interesting because now we could just cancel this thing out right here. And then we get, and this also cancels out, right? This also cancels out, so we get x over 4 is equal to this right there. And if you multiply this thing out, Okay, you get x squared plus 4x plus 4, right? Okay. Oh, wait a minute. I did something wrong. I did something wrong because, let me see. Something is not right here. Either I didn't copy it right or something is not right here. X squared. Hmm. Oh, there was a 6 here. Sorry. The original problem. Yeah, I'm sorry. My handwriting is awful. Okay, there was a 6 in here that I didn't write before. Okay. So the original problem actually had a 6 in there, which I didn't see. So it makes it a little more challenging. So this goes like this, parentheses, and 6 times 6 is actually 36. So therefore, this cancels out. I'm going to erase this one. 36 divided by 4 is 9, right? So it's going to be 9x right there. Okay, yeah, because it's my handwriting. Okay, so make a note to yourself to write a little better because, I'm writing notes and sometimes I cannot read my notes. Okay, anyways, we can figure that out. And then now we have to make it equal to 0, remember? We have to factor again. So solving for the roots. That's why this is the reason why you have to learn this, factoring polynomials, because to solve stuff like this. Okay, and then you gotta do, actually this is 4x minus 9x, right? So it's gonna be negative 5x right here. Now you could go ahead and just put negative 5x right there, and then it's plus 4. Okay. So now you have to remember the x method to factor. So we have, we have negative 5 and 4. So this becomes something times something is negative 5. And when you add them, okay, when you add them, it becomes becomes 4, right? So if you were to factor this, right, to factor, and then 4 and 1, negative 1, negative 4, right? So something times something is 4, but when you add them, it becomes negative 5, okay? So this is the little, I mean, you don't have to use this, but remember we're using this graphic organizer. So that helps you to factor out, and make sure you check it, okay? So now we solve for this. So x minus 4 is 0, x minus 1 is 0, so x is 4, and x is 1, right? Now make sure you check it back, and it meets the domain restriction. So it looks like they both work, okay? So this one works, this one's okay. Okay, and my handwriting is awful, let me write it in red. Okay, it's 4, okay, 4. Okay, so this one works and this one works, so they both get a happy face. Okay, now for the last challenging problem. Okay, this is the one that a lot of students have problems with, and let's go look at that one. Okay, so right here. Okay, let's go take a look. Okay, so this one right here is the most challenging one. Let me change the color to blue, back to blue again. Okay, so we have a log 3x plus log 3 parentheses this right there, right, is equal to 3. Okay, they ask you to solve this one. So again, check the base, make sure the base is good. Remember, we're adding now. So in log, when you add, it becomes a multiplication, okay? In the property of logs, remember, when you, the law is the property of logs. When you subtract, became division. When you add, it becomes multiplication. So in order to write this as a single log, we're gonna write this. Yeah, my stylus is acting up. I think I use it too much, but I have to really focus. 3 to the third power. Okay, again, we're gonna convert, right? We're gonna convert. The base is 3, so 3 and this right here is going to switch, which is the one we went over. I'm applying this, the property right here, the definition of logs, right there. Definition of logs, that's the one I'm using, okay? So still nothing new, okay? Okay, let me move that out of the way. All right, so we have this right there. Okay, so now the log is done, okay? So this is gonna be another polynomial that we're gonna have to solve, okay? So now this is, again, review of solving for polynomials. 3 to the third is 27. Let's do the distributive. And then we have 0 is equal to x squared, 6x. Move the 27 to the other side. And let's do our x method again. So it's going to be -6 right there, -27. So what times what is -27? But when you add them, it's going to become -6. Well, these two are it, right? -9 and 3. So we have our little factorials. Okay, and then we solve for it. We get x equal to 9, or x is equal to -3. Now, be careful here, because when you plug in 9, 9 is okay because they're all positive. But when you plug in -3, for example, to here, for example, I'm gonna make it red here. When I check and put log base 3 to the -3, now is that possible? No, because remember, domain restriction, this value cannot be negative. Yeah, my pen's at, let me slow it down a little bit, maybe that'll help. It's -3 right there, right? So that cannot be negative. So this is undefined. Okay, or it doesn't work. Okay, it does not work. So only answer for this one. Okay, we need a little drum roll. Is this one, okay? Remember, that's the only one. The other one, this one does not work. So this is the only answer. And you have to check your answer to get that right, okay? So I hope you enjoyed this video. I know it's a lot. Please feel free to watch it again and look for it again. And I'll answer the most common questions as best I can. And I'll see you on the next video.